from the middle of a single linked list. So for the current list we're looking at, we have our head, we have our node storing Mick, our node storing Bruce, our node storing Johnny, and our node storing Timmy. So for the list that we're maintaining, we're going to refer to these through their numerical position. So Mick is in position 1, Bruce is in position 2, Johnny is in position 3, and Timmy is in position 4. So when we want to remove something, or to remove a node from a single linked list, we will remove it via an index or a numerical position. So if we want to, for the example that we're going to do, we will remove Bruce from the single linked list. So if we're going to remove our node, we're going to remove it via the numerical position. So when we call our remove method, we'll pass an integer parameter to the method to remove the node that's stored in position 2. So once we've identified the node that we want to remove, so let's say we're dealing with Bruce, we will basically treat Bruce as current. So we'll take our address of Bruce. So we're going to take the address of Bruce, basically the object, and set the current pointer to point at this object, which is Bruce. And we're going to set the previous pointer to Mick. And we have this stored in previous. So we're keeping two variable references, one to the previous one, which is Mick, and one to the item that we're going to remove, which is current, which is Bruce. So we have these two here. So let's think of the logic of what a remove operation is going to do for us. We want the node named Bruce to be removed, so our chain should be going from head to Mick, and then we're going over to Johnny and then to Timmy. So Bruce will be gone. So what we need to do is we need Mick to bypass Bruce and to point to Johnny. So what we need to do is we need to be able to tell our node called Mick how to be able to find the node named Johnny. Now, we already have that information. The node that we're removing, named Bruce, knows how to point to the object named Johnny, and it knows this from the reference that we have here. So what we'll be able to do, we'll be able to take our value named Bruce, and we can take this address and we will set the pointer in our node called Mick to point at the memory or the object named Johnny. So what this has done is it literally has see, one of these might do the job. What this has done for us is basically our pointer has been allocated to basically come straight over here and point at Johnny. Just try and squeeze him up ever so slightly. Okay, I'm doing a bad job on that line. So basically that one has basically pointed straight over here. So we've broken the chain here. That link is gone. So now the object named Mick points at Johnny. So we're coming straight over here in this direction. So basically we've broken the chain. Bruce has been removed and we're gone. So we can literally, once we have our chain broken, this has removed Bruce from the equation for us, and Mick, the object, the node named Mick, now directly points to Johnny. So it's going from head to Mick. Mick knows how to find the next object, which we've set to Johnny, and Johnny knows how to find the next object, which is Timmy. Timmy's pointer holds a value of null, which indicates that it's the end of our single linked list. So what we've just run through is a kind of graphical representation of how to add and remove from a single linked list. So for each method or each action that we've performed for add and remove, there was 3 options. If we're adding something, you can add to the head of the list, i.e. to the front. We can add to the end, or we could insert a node into the middle of a list. And it's the same for remove. We should be able to remove from the end of the single linked list. We should be able to remove something from the middle of the single linked list, and we should be able to remove something that's stored in the front of the single linked list. So when we're actually going to implement this in Java, we will programmatically have to deal with those specific cases. So for add, we will have three pieces of functionality. One, to be able to add to the front, to add something to the front of a single linked list, to be able to add something to the end of a single linked list, and we'll have the functionality in Java to be able to insert something or add something to the middle of our single linked list into a very specific index position. And it's the same for remove. We should have the functionality inside Java to cater for adding to the front, adding or removing from the front, removing from the end, or removing something from the middle. So what we're going to do now is we're going to create a NetBeans application from scratch, and we're going to build up the functionality of our single linked list. So what we'll use as this example is we'll make a start on the lab work, which is the train example. So first and foremost, we will implement our single linked list, get it working or get it operational, make sure that we can store carriage objects, i.e. be able to add a carriage to a particular train, and then we'll put a graphical user interface around it. So we'll start into that process now.